Welcome to Manohar Chemistry YouTube channel. Today I am going to explain classification of elements. In that, so what is the need of classification first? So classification will give clarity for you people. Elements will come under metals and which elements are come under non-metals and which elements can come under gaseous state. Which elements will come under gases. So if we know the physical state of any element, then we can predict its properties very easily. If you know the physical state of element, then we can predict its chemical properties as well as physical properties too. So that here nearly 118 elements are there. These 118 elements are classified into 4 blocks based on its electronic configuration: S block, P block, D block and F block. So how can we classify these 118 elements into 4 blocks? So here electronic configuration is a main criteria. In that, in electronic configuration, they followed differentiating electron is one criteria. Based on differentiating electron, these 118 elements are classified into 4 blocks. That is S block, P block, D block and F block. Definition of S block elements. In which elements differentiating electron present in valency shell of s orbital. Valency shell of s orbital. Such type of elements come under S block. So here we know that s orbital can accommodate only 2 electrons. So that's why S block elements are classified into 2 groups, that is first A group elements and second A group elements. In first A group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So here hydrogen is a gas, remaining all elements are metals. Hydrogen is a gas. But here why hydrogen kept in first A group elements? Just you see their electronic configuration. In case of hydrogen, that is 1s1. So in case of lithium, that is helium 2s1. So by using inert gas electronic configuration, we can represent electronic configuration of all elements in short form like this. So lithium, so helium 2s1, sodium, neon 3s1. Similarly 4s1, 5s1, 6s1, 7s1 will come. So just you observe valency electronic configuration of these first A group elements. In that, all elements having 1 electron in its valency shell. So that's why because of this reason, remaining elements which are present in first A group elements. So because of electronic configuration similarity, because of valency electronic configuration similarity, so this hydrogen kept in first A group elements. So now these first A group elements are called alkali metals. So actually alkali stands for base actually. So these first A group elements, oxides, when they are reacting with water, they will form bases. So base we call it as alkali. So that's why we call them as what? Alkali metals. So for example here sodium oxide is there. When sodium oxide is reacting with water, then it is going to form sodium hydroxide, which is base. So when metal oxides reacting with water, they will form bases. Because of this reason, these are called what? Alkali metals. And second A group elements. When you go for second A group elements, so beryllium, magnesium, calcium, strontium, barium and radium. So just you see these elements electronic configuration. So these all having in valency shell, these second A group elements having NH2 as a general electronic configuration. Why? Because these all elements having 2 electrons in its valency shell. These second group elements are called alkaline earth metals. Why? Because these oxides also will form bases when they are reacting with water, and these elements are available in earth crust. So that's why we call them as a alkaline earth metals. And here these all elements are metals except hydrogen. These all elements, first A group elements and second A group elements are metals. So that's why they are always willing to form ionic compounds except lithium and beryllium. So these lithium and beryllium will prefer only covalent compounds. Why? Because of small size. These lithium and beryllium always willing to form covalent compounds. Other than that, except lithium and beryllium, all elements are willing to form ionic compounds. For example, which is very familiar compound, that is sodium chloride, table salt we can say. This table salt is a attraction force between sodium cation and chloride anion. So it is very familiar example, and these all are metals. So that's why they are willing to form, every time they are willing to form ionic compounds only, right? And they are very soft metals, and these elements are willing to release electrons. Metallic nature is nothing but willing to lose electrons easily. When when these metals are willing to lose electrons easily, these elements undergo oxidation. Oxidation is nothing but what? Increasing in oxidation number. So for example, sodium is there. Sodium will lose one electron and it will form Na plus. By losing one electron, it will form cation. Means it undergoes oxidation. If another element, for example chlorine is there, chlorine will accept one electron and it undergoes reduction. Means chlorine oxidation number 0 to minus 1 means decreasing. Sodium oxidation number 0 to plus 1 means increasing. Sodium undergoes oxidation and chlorine undergoes reduction. So because of whom chlorine undergoes reduction? Because of sodium. Because of sodium, chlorine undergoes reduction. So sodium is responsible for the reduction of chlorine. So that's why here sodium is called what? Reducing agent. Not only sodium, the elements which are present in this first A group elements, they will act as a best reducing agents. But we know that reducing agents will undergo oxidation. Reducing agents undergo oxidation, but they are responsible for the reduction. And these are having low melting point and low boiling point, and they will show characteristic colors when we introduce these elements into the Bunsen burner. When we are introduced these elements